I can say, there's number 3, number 4, number 5, and we're rambling about number 6. And they can pause and they can look at that line by line, step by step. So in this case here, the order of operations says that you are taking 2.5 to the 4th power. And then you're making it negative. In other words, you're taking the opposite of 2.5 to the 4th power. In this case here, because the parentheses have to be done first, we consider the 2.5 as a negative value. Therefore, that negative value is what happens 4 times over. Those exponents are after. If exponents came and then parentheses, then they mean the same thing, but that's not the rule. Wouldn't be 9. We don't add them. We don't multiply them. So, we have to follow the rules because otherwise the math doesn't work. It's really crazy how well it does work when you do follow it. It's like that box. It's eloquent. Not elegant, eloquent. Yeah.
So you multiply inside parentheses first? No, on 3.
3?
Yeah.
You multiply because within the parentheses you still do exponents, multiplication, division, addition, subtraction, order. Yeah, you have to work within the parentheses. So you work from the inside out. So this is the first thing. Then you add that, and then you subtract that, and you multiply by -5. Just like here, you do the multiplication first, and then you put them together. So does this come out then to 39.0625?
Yeah.
It does. Now we can just simply look at this when there's a power of 4. That means we're multiplying a negative 4 times over. So that will be positive. And then you can just ignore it and say 2.5 to the 4th power. That's kind of the shortcut of this. Just like the shortcut here was to say, oh, my answer is negative because there are 3 of them. Because every 2 makes a positive. Every 2 negatives make 1 positive. And then you can ignore those negative signs and make it more simple as you crunch the numbers. Any others we should look at?
7.
Evaluate -1 times -5 times AB. When A is -1.2 and B is 4/5. So what hangs you up there?
Multiplying the A times the B like that.
Okay. So A is how much? Negative 1.2. And B is 4/5. Okay, it's all multiplication, yes? So we can do it all in any order we wish. How many negatives are there?
3.
So your answer will be a negative.
That's not what it says. Yeah, the answer's positive. I got a negative.
So it's a negative, and this is a -1, -5, and a -1.2, and that's not a negative, is it?
No.
Well, then they're wrong, right? So, I mean, think about how many problems are in this book and how many answers they have to have. This is the lesson masters, plus the book. Do you think there's room for error?
Yeah, but I've never come across it.
You haven't?
Yeah.
There are not many, but every now and then we do. The geometry book's got a bunch of them.
Wait, so then what is it?
Well, the answer is negative. I mean, we got to do what we know is right. And we're good with this being a negative answer?
Yes.
Okay, 1 times 5 is 5. What's 5 times 1.2?
6.
6. Just like 5 feet is 5 times 12 inches is 60 inches, so that's 6. And then 4/5 of 6 is
4.8.
4.8. Yeah. Just like 40 inches is 4 feet out of 5. So you can relate a lot of those things. Okay. So we good? Did they get 11 and 12 correct?
Yeah.
All right. Number 10, the product of any number and -1 is negative. When is it not negative? When the number is 0. You bet. Good show. Welcome back. The product of two negatives is negative? Never. Can't happen. It's always a positive. The product of a positive and a negative has the sign of the number with a larger absolute value. Yeah, sometimes, but don't use that rule. That's for like addition. Like this. This has a larger absolute value, therefore it's the sign of the answer. And that's one thing that they treat as a rule for adding integers. And then you find you take the one that has the larger absolute value, that's the sign, and then you subtract the absolute values, that's the answer. That's not necessarily how I taught you, but that's okay if it works for you. Okay, now, the last part of this thing here on the bottom. A couple of you started it, and let me get rid of this. I'm going to bring up this one here. So what we're supposed to do with these is we're supposed to graph based upon what they tell us. And the first one, 13, is just to graph the image. So you're looking at the pre-image, the starting, of any g under a size change of a magnitude of negative 0.5. So with that negative 0.5, you have to multiply that by all of the coordinates. The x and the y. Yeah, when you're doing a size change magnitude, I know we did these, it was a while back, and it was fuzzy when we did it, because it was the first time you saw them. There will be things, I'll tell you, in this book that they're going to be fuzzy to you because you didn't do much work in the previous book. The previous book would have laid a lot of the groundwork. So, but, you know, we'll figure that out, and we'll work it out. And this is the first time that I'm going through this book without having done the other book either, so. So an example of what you would do is you would take each of these 3 points, N, E, and G. And if, for example, I took point E, what's the ordered pair for point E?
Negative 2.
And positive 2.
Yeah.
Okay, so for each of these points, the size change magnitude is going to be this. So what you're going to do is multiply that by each of these. You may recall when we did other size changes, to make something larger, we would multiply both the x and the y by the same number. And what that will do, when you multiply it by the same numbers, it'll change how far away from the origin everything is. So in this case, instead of it being twice as tall, twice as high up, it's going to be half as high up, but in an opposite direction. So if we did 0.5 times 2, it would be 1, but it's a negative 0.5, so that's a negative 1. And the negative 2 value is going to be half as big, but it's going to be the opposite sign. So half of 2 is 1, but instead of it being a negative 2, it's going to be a positive 2. So this point, which starts out here, is going to move to here. That's where E prime is going to be. So then you're going to plot that onto here. We'll mark there, mark it E prime, and then do the same thing for points N and G. So why don't you go ahead and spend a minute on that. Make sure that you feel comfortable doing those. Put your work on paper. Organize your numbers. Try not to do too much of it in your head. And then when you connect the points, connect them with a straight edge so it looks all nice and professional. Is it an expansion or a contraction? Does it get bigger or smaller?
Contraction.
Contraction means getting smaller, expanding means getting bigger. Does it get bigger or smaller? I don't know. Well, you'll find out. Well, what you have to do is get, so your E has to go to 1, -1. So it's 1 over and 1 down. So you begin by plotting that and begin at 1, -1. Do you understand how I got the 1, -1? Okay. So plot that new point, 1, -1.
I'm just thinking.
And then do exactly the same thing to point N that I did to E. And do it to G. And then when you plot all three of those, then you can see the shape of the new triangle. This is right, I don't know. We talked about what it was going to be yesterday, right?
Yeah. Negative.
Everything's half as long. Yeah, and you got rotated 180 degrees.
Yes.
So that's the opposite.
Positive now.
So when you do it, actually more negative,
So it would be.
you can say they're going to go that way, but this is here, they're going to go that way, so that, and this. And that's a real rotation.
That's it.
So you're not going to get,
Anything
it doesn't
comes
matter
in.
if you do like
So
positive.
that would say zero, and then, but it's maybe.
So negative is going to start.
Are you guys doing? Would it be this or the
Or up, negative.
Do it point by point.
What is it here?
Yeah, it's partially correct, but not completely correct. So when you go to 1, -1, where is it?
Okay, wait, are you guys doing?
Start plotting
We just did
these
that.
points. You can do this.
We did two. We didn't do easy. These are easiest.
You have to do
Oh, I think
this
it's
number.
No.
But the negative is 0.5 times 2.
You would be right here. One
The
over
negative
that.
0.5 times 2.
And then. Not connected. If you
One
want.
by this, so what's happened with 2? Is a negative.
Kind of creepy, you know that? Kind of cute.
Now, negative of a negative. So that's G prime. So write that on the graph. How we doing over here? You look like you're resting.
Oh, I'm working on it.
No, that's fine. Okay, you get that in first? How are you?
Got the numbers.
It's definitely still at zero.
Yes, yeah, it is.
Okay.
And you don't look back here, so- Oh, you don't. So this is point n, right? So put an n there. And then this is going to be n prime. But if you took a negative 0.5 times 0, that's your answer. So a negative 0.5 times 4, yes, half of 4 is 2, but it's a negative. So that would become a negative 2. Yeah, yeah, we're multiplying by negative 0.5. You guys remember when we did this the first time through? Like a month and a half ago? I set up a table like this to help you organize. So here we have the x's and the y's. And then over here, this is going to be a negative 0.5 times the x and a negative 0.5 times the y.
Yes.
That can help you organize this. And it can also help you see patterns. So what we came up with here was a 1, negative 1. So this is half of this number made its opposite. Half of this number made its opposite. So half of 0's made opposite is 0. Half of 4 and its opposite. So there's a pattern to how these all go. You start seeing the pattern, they work real fast. That is unlucky. Part of it is correct, but not all of it.
Oh, it's negative.
Yeah, but you're gonna have to do some erasing. You need a red pencil, buddy. With an eraser. This one, that came out a little funky.
Yeah, no, that one's far over, but so, like, it kind of looks weird, but
And half as far, think of it like this, from the origin. It's half as far away and in the opposite direction. Oh no, that's right, I'm sorry, it's 1.5 times as far away and in the opposite direction. So it's going to be 1.5 times as far away, but in the opposite direction. So it's going to be over here. And then it's going to be half 1.5 times as far away. Is this 2 over? So it's going to be 3 over in the opposite direction. And it's 2 up, so it's going to be 3 down. If that's 2, it becomes 3, 3. In the opposite direction, that's fine. So something else is not correct. Where's the, that works. This one. 1.5 times as far would be this way. And it's up here. I think when you do that, all of a sudden you connect your points in the same order as the original image is going to come out. How are you?
Right after you say 4 times.
Both of those? I'm probably going to move on. Looks like you got it. Yeah, it does. That makes sense. I'm probably going to move on and let you guys struggle with these on your own.
it's just like an S. It's cute.
Good. Yeah, they will be negative 1.5. All right, so break for from what we were doing. We're gonna go in another direction now. I'd like you to try to finish these to the best of your ability, if you haven't. I think almost all of you have finished up on the first one, and you can see that it's a rotation, and it's only half as big. So when we multiply by negative numbers for size changes, face cover. Not an option, thank you. Not an option until we're all vaccinated. So when you see a negative number being multiplied to each the x and the y, everything goes in the opposite direction. That results in a rotation of 180 degrees. And then when a number is bigger than 1, it's going to be an expansion, and when a number is smaller than 1, it's a contraction. When it's a negative, anything more negative than -1 is an expansion, and anything between 0 and -1 is going to be a contraction. So, in the big picture, that's in the top narrow band of the kinds of things that I want you to be able to master at this point. So if you're looking at this and you're saying, hey, this is really challenging to keep up with, don't be discouraged. This isn't going to be make it or break it, and we send you back to 7th grade next year. Not at all. This is something that we keep building on. We introduce it now, and you'll see more and more of it in another 2 years from now. You'll see this stuff on peaks.
That's fine.
Yeah. When, you guys you didn't do peaks last year. You did not do peaks last year. We were in COVID last year for peaks. In 6th grade, you did it. And if you feel like in 6th grade, a lot of what you saw in peaks was like, huh, what's this, what's this? In 2 weeks here, when you do peaks, you're going to look at it and go, oh, look at that. Now, I've seen that, I've seen that. There'll be a lot more that you will have seen. All right, so let's set this aside, and I'd like to move on to the next lesson. And I'm going to abbreviate your introduction to the next lesson because there's just a few points that I want you to really take home from it. I need to get a little bit, yeah.
Right, use the geometry.
Your book? No, you don't need the book. Just okay, something like that. One colored and one white. Is that good? Yeah, one colored and one white. If I can get that accomplished, I'll be happy.
Wait, is this correct?
I gotta see the regular to be able to compare.
33. What is that? Let's see that.
Snake eyes is one.
Oh, yeah.
Spiders.
Spiders.
Oh, you need color? You need the color? Ryan, do you have a color and a white? Okay, so we have 2 die, correct? All right, I'm going to start out with just a question for you, and I want you to spend a little bit of time trying to figure out what the pattern would be for you to be able to determine probability of something. So first off, if you just took your colored die, how many sides? 6. Okay, how many ones are on here? Okay, so what's the probability, if you just roll this red one,
1/6.
that it lands on top of your head? What's the probability of getting a 1? 1/6, okay. Isla, I need you here, please, okay? Go to the white one. What's the probability of getting a 1?
1.
Okay, good. So here's my question for you. You have 2 die. What's the probability of getting a 1 on each die?
1/6.
Hold on. Stop. I want you to think about this quietly. And I'd like you to see if you can come up with a pattern for how to mathematically determine this. And do it on your own. And don't sit here and repeat 1/6 over and over again, or you'll be doing that up in the cafeteria. Don't sit there and laugh at him, or you'll be laughing at him with him up in the cafeteria.
I don't want to do it.
Oh, good. No, I know. Don't laugh at him either. He's no less important than I am. Yes.
Do you mean like roll 1 on both die, or just roll 1 on one die, at least?
Have it come up like this.
Snake eyes.
The probability of getting a 1 on each die. You really need to roll them on paper. Okay? When you think you have something, get my attention.
Because like it's
Keep looking.
because if you're like everything has to be the same.
Action.
So
Wait, no, but that's.
like it's like okay, there's one side, two side, two side, one side, one side. But then there's like other like so you just do one
Keep thinking about it.
Oh yeah,
You have something? Every else is open for
so
vote?
it's like this side and this side is, and there's one out of the ball that goes off in
Good job. That's the math right there.
I am a math teacher.
Yeah, we'll go that way.
I think we go like this. I'll say, I think it was one small. So I got 2 rolls.
Your soulmate starts with T and 4 letters.
Yeah, you got it?
No, got it.
1/6. Oh, that's 9.
How many times?
Where's 36? No. 12.
See, no, but then it's physically impossible to get it A or a Z.
36 means nothing.
Right.
But they have to add
It's
like,
bad, guys.
It could be 24 tries. Yeah. But then you can never get to the letter A. I have no idea.
So I'm going to give you 1 more minute on that.
I got 1/12. What do you mean? On each Oh, I thought it was on both sides. It is on both sides. Both sides combined. Yes. Yes, that's what I thought.
You can always say, I guess it's either happen or it doesn't.
I think you need to read that.
I don't know how to do it.
1/6 for a chance.
Rolling 7.
No, it's 1/12 for a single one and one out of 144.
Okay, like 15 seconds, I'm gonna call you back up here.
Yes.
Okay, so, I've been listening to some of the things that you're talking about, and what I'd like you to try to do, I could call on a couple of you if I could. I'd like you to try to explain in 3 sentences or less why you believe what you believe. You started raising your hand. What are you gonna say? Say it to everyone so they can hear.
Well, there's 12, the total, there's 6 sides on the one dice, but adding those two, it's 12 sides. And there's only one possibility that combining those two, that it would become both of them having it. So I think that would be 112 instead.
Okay, can you hear that in this big room? So she says that there's 6 different choices on one, there's 6 on the other. And combining that idea, there's 2 choices then of the one from each, out of a total of 12. So you're saying it's 2 out of 12. Okay, Ariel, do you want to carry that further?
No, I think I have a different answer.
What do you think?
I think it's 1 out of 36 because there's different combinations.
There you
Like
go.
you can roll a 1 and a 5, a 1 and a 7, or a 2 and a, not a 7. Like a 2 and a 3, but there's 36 combinations, and a 1 and a 1 is just one of those.
Okay, so what Ariel's saying is that this one here is not dependent upon what is on this red die. So this one could come up with 6 different ways on here. This 3 on the white die could come up with 6 different possibilities on the other die.
6 times 6.
So that turns into 6 times 6. Selby?
But 1 times 1 is 1.
Excuse me, Selby?
So if we have 1 dice, we've already calculated that it's a 1/6 chance of getting the 1. But
Okay.
then you have to add another dice, but it has to be dependent on the other dice to get that same answer, to get both of them the 1. So I think it's 1/12, because you have to slice the probability in half, because you have this other dice. And then you have the other.
So we certainly have 2 different die, don't we? And each one of those die individually has a 1/6 chance of getting a 1. Is that right? So some of you are saying add, and then some of you are saying multiply.
Yes.
Did any of you draw a picture of this?
No.
I started.
I'd like to present a picture to you on this one.
I remember seeing.
Oh, I remember that.
Ryan, are you taking a look up here? Yeah, we want to walk out of 8th grade with this one solid.
136.
Do you need the picture explained?
No, 136.
Okay.
All the numbers.
Yeah, so all of these across the top row are if the colored die is a 1. And the white is independent of it. In other words, regardless of what the colored die gets, the white has an independent probability. It doesn't depend upon. In other words, when the red one is a 1, that doesn't make anything else happen. So, when these things don't depend upon one another to see how they come up. They're not stuck together, are they?
No.
So you throw the colored one, you throw the white one. They each have their own independent chances. And this is where the vocabulary of probability gets really, really messy. And the book is heavy and big on this word independent events. Just realize that when you have 2 things that one is not affected by the other, you gotta multiply. when one is affected by the other, then you have to add them. And we'll come to that next year. But in this case here, if the colored is a 1, there's 6 different ways the white can come up. So there's 6 possibilities. If the colored is a 2, there's again 6 possibilities. If the colored is a 3, there's 6 more possibilities of the white. So all of this gets multiplied out. And if we look at this, there's only 1 out of all 36 combinations, which is a 1 and a 1. So what's the probability of getting 2 6s?
136.
It's going to be 1 out of 36 again. But the probability of getting doubles,
Cut in half.
yeah, it's 636. Because what we're doing is we're putting together all the individual 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6, and we add those up. Okay, so 8-4 is called multiplying probabilities. Probabilities, is that spelled right? That doesn't look right at all. Probabilities?
P-R-O-B-A.
Yeah, help me
Yeah, that's
here.
right.
Is that okay now?
Yeah.
Yeah.
Yeah, we need you to help me. My spelling is less than desirable. So they get into some formal things. They use this word independent events. And independent events are 2 or more events that are separated from one another. They don't rely upon one another for them happening. They don't affect one another. So whether I roll the color one in this room and the white one in another room, or I roll them right next to each other, one does not change the other's outcome. So we did a little of that last year. I looked back at it, but we didn't do a whole lot of it. They like to use, with this stuff, they like to use spinners.
Yeah.
Two-thirds.
If, in this case, those were divided evenly. You might want to write this down, I don't know. The probability of a win is what?
Two-thirds.
2 out of 3, yep, 2/3. I really like leaving probabilities as fractions as much as possible. Because if you change that to a decimal, it's 0.6 repeating. And that's hard to work with numerically. So what's the probability of a win followed by another win?
Impossible, it's all one's good.
Well, when we do this, when we say something and another, that is implying that there's a second independent event that gets coupled together with this. So what this means here is the probability of 2 wins in a row. That's what this means. So how would you calculate that?
Two-thirds times two-thirds.
Yes. The first time you spin, that probability, and then it gets multiplied again by 2/3. So what is 2/3 multiplied by 2/3?
4 6.
Again, 4
4 9.
4/9. Yeah, let's make sure we multiply our fractions top to top, bottom to bottom. So it's almost a 50% chance of winning twice in a row, almost.
0.5 off,
Yeah, well, it's more than 0.5.
at least below.
4/9 is 0.4 repeating forever. Yeah,
What about like 3 or 4 times?
excuse me, what?
What about 3 or 4 times in a row?
Yeah, what about 3 or 4 times in a row? Let's do that. So what's the probability of 3 wins in a row? Well, each time we spin, it's independent, so we multiply them. So that would be 2/3 times 2/3 times 2/3. So what's 2 to the 8 and 27?
Yep.
Yeah. Clover.
Is there a trick, for when we get older, is there a trick, to that we don't, like, use
A trick for this, making it quicker and easier? No, you just have to look at the independent probabilities, and I don't think that there's an easier way of looking at it that I've ever seen. I've studied probability more than this has ever been. And yet, all they do, the higher you go in math and you do probability, the more complicated they make it. But it's all based upon this same idea here.
Could you use, exponents?
So what?
Could you use exponents?
Could you use exponents? Sure, you could use exponents. I guess that's a good point. Let's say the probability of losing 10 times in a row.
That's my goal.
So what's the probability of losing once?
3/5.
It's 1/3. So 10 times in a row would be 1/3 times 1/3 times 1/3, which would be that taken 10 times. That goes a little bit beyond what we're doing in this lesson, but to answer your question, that's how you would do it. I don't know what 3 to the 10th is. That's a pretty big number. So it'd be 1 out of whatever 3 to the 10th is. So, but this is above and beyond what we need to know to be able to do our work. So I have a limited number of problems from this that I'd like you to work on.
Mr. Daniel?
Hi.
If there's P, parentheses, 3 wins in a row, is there a simpler way to write that?
Isn't it just 2/3 to the 3rd power?
It's 2/3 to the 3rd, yes. But is there an easier way of writing that?
Like, you just go 3.
Let's look at this lesson, master, and you'll see another way that they write things. Show you some of this. That is what that, I'm not giving you all these problems. Okay. Do we all have one now?
Next is slide 34. But is that top behind?
Careful about just racing through here,
Orion.
because you don't have to do everything.
31.
Okay. So in this case here, if you look at number 2, they use capital A and capital B to name the events. What I did here is I wrote the word win. But I could have called this event A. TJ. I could have called that event A, and I could have called losing event B. You hear what they do? Here they say A and B are events. So like if I look down at this one right here, A is a probability of winning of 0.2, which is the same as 1/5. And B is a probability of happening is 0.55. So if it's A and B happening together and they're independent of one another, this is a shorter way of saying the probability of Miriam's team winning and what is the other one? The Sam's soccer team winning. So to answer your question about is there a shorter way to write this? Yeah, we define abbreviations. Here they say A is the event that A is Sam's team wins. B is that Miriam's basketball team wins. So the probability of both of them winning is their independent probabilities being multiplied together. So if I said here that A is winning and B is losing, the probability of A followed by B could be written with letters rather than words. So not always is it shorter. So the questions that I'd like you to do from this are not all of them. So give me a second to show you what they are. Well, that's no problem. This is 8-4, right? There they are. 1, 2, 3, 10, 11, 14, 15, and 18. Those are the only ones that I would like you to focus on.
10, 11, and what?
14, 15, and 18. So the box, if you understand, on the box. Yeah, trying to, I don't know, wait for you. No, yours doesn't take this. You still have to use the white one.
Yeah, what? Okay.
Wow, that went fast. Sort of.
Yes.
What do you?
What do what?
Numbers are up there.
Independent means that the probability of one is not affecting the other. Your dice. One die does not affect the other die. They happen independent of one another. Yeah, do you mind throwing these in here when you leave? Thanks.